Okay, I heard a 7 point something. Whoops. We're going to switch that up. Sorry. Pen. Okay, and my computer locked out, so we'll see what happens here. I heard a 7 point something. We got to watch out for that. So I know where you were going with it. Okay, we weren't going to 7. Where you were going was 0.7. So as it's marked out as the tenths. Okay, so we would be able to say that it is greater than the 7 line, but it is less than the 8 line. If we report that as a 0.7, we've now lost information. Okay, the information we've lost is it's not at the 0.7. It's actually higher than 0.7. So when we observe that in this analog system, have to specify an extra place. We're allowed one guess. So in this case, it becomes 0.75. Some people are like, 5. Exactly, it's a guess. Okay? And really that guess can be anything in there. We just want it to be as close as possible to the actuality as we can. Kind of make sense? In that measurement, how many significant figures do we have? We've got 2. Right? The 7 and the 5 are both significant. What if we switch this up and we now say that's 1,000 instead of... Okay? And so now when we go through and look, those markings now are all to what? Hundreds. So we're for sure about that 7, right? So I could write 7 and we'd be good. No, okay, so when we're saying that 7, we're saying that 7 belongs in the hundreds place. Okay? What else do we know?
It's in between, so approximately 5, 0.
Again, same deal, approximately that 5. That 5 needs to get placed where? In the tens place. Do I know anything about that number? I know that blue box, so I think I know where you're going. Vague question. Do I know anything about the number going into the blue box? No, I know nothing about that number. Okay? But I need to ensure that when this number gets written out, that 7 goes into the hundreds place. Okay? How can I ensure that? Well, one way to ensure it is to make sure that we have a number line where we've specified all of those places. And so now we know where the 7 is. It's in that second one. It's in the hundreds place, right? Okay. But that would mean, depending on my measurement, I would have to have all of the number places specified. Okay. So what is the smallest number place? It's infinite. So doing our reporting based off of number places doesn't make sense. We wouldn't actually be able to write any number down because we'd have to fill out all those number places. Right? So we had to create a system that allowed us to still maintain the information of the number line, but without adding more information or taking information away. Okay? The way we did that is we used 0. The problem is that 0 has 2 different meanings. It has the meaning of don't put any number here because we don't know anything about it. And then there's also the meaning of 0 where it is
Exactly 0.
exactly 0 becomes vague, but I understand where you're going with that. Not the number 1 through 9. So 0 holds 2 different meanings. Okay? Deciding when we look at a number which meaning it has becomes tricky. Okay? And that's the point of our significant figure rules. Okay? Because when we look at our measurements, we want to be able to report that information as accurately as possible without adding more information than the device allows or taking information away. And that's ultimately why we have significant figures. Right? So how many significant figures do we need? Well, if we were to measure feet in this room, we don't need that much. We could probably get away with 1 foot and then 1/10 of a foot and be fine. But if I want to make it to Mars, how many significant figures do I need in pi? Something like 10 to 15 places. If we don't have 10 to 15 places of pi known, what happens? We miss Mars and we fly off into the nothingness of space. Okay? So when we're looking at really large different distances, we need lots of significant figures to ensure that we hit the target that we're aiming for. Okay? Well, but we're talking about chemistry, and chemistry isn't really large things, it's about really small things. Exact same issue happens the other direction. Okay? So we need to be careful with our significant figures because we're dealing with things at very small levels, or we could deal with things at very large levels. This becomes exceptionally challenging for the average person to deal with because how often do you in your everyday life worry about traveling to Mars? Okay? Or trying to count or measure the size of an atom. Okay? The world that you deal in, we don't need a lot of significant figures. Okay? We can work with them as absolutes. We can't do that in science. That's why we have these extra rules. That's why you have to learn and use them so that they're used appropriately. Okay? So if we looked at these significant digits, in theory we all watched the video and we all know these answers, right? We did that like 4 weeks ago, and then we talked about a bunch of other stuff and you probably forgot it all, right?
Yes.
Yeah, okay. Figure it out. We got 8 questions. Figure out the sig figs. Okay, so if we take a look, we'll start with 1. To me, the most important process for doing this is actually underlining the significant digits as you go. So for that first one, the 1 and the 2 are significant according to rule 1. Okay? Now we have to decide, is that 0 significant or not? Okay? To decide if the 0 is a placeholder or holds the value not 1 through 9, which I know is a mouthful, we have to evaluate about a decimal point. Okay? Whether there is an explicit decimal point versus implied. Okay? So in this case, there is no decimal point specified, so your 0 must be controlled. So we have to have a significant digit to the left and to the right. So look to the left of that 0. What do we have? Significant digit. For those people shouting 1, that's not necessarily bad, but that's not what we're looking for. What we're looking for is a significant digit. Look to the right, significant digit, which means that 0 is a significant digit. All 3 are significant. Okay? Next number down. The 1 and the 2 are significant again. Okay? Kind of a pattern there. They're all 1s and 2s. Okay? Is the 0 significant? Okay, so again, no decimal point. So we look to the left. What do we have? Significant digit. Look to the right. There's literally nothing written there, which means there's not a significant digit there, which means that 0 is a placeholder, not a significant digit. So we only get 2. Next one. The 1 and the 2 again, but now this one's different because there's an explicit decimal point, which means the rule changes. There is a decimal point, then the 0 needs to be immediately preceded by a significant digit to be significant. So we move to the left. I should have said to the left, not preceded. I apologize for the stupid wording. Okay? To the left. Is there a significant digit to the left of that 0? Yes. What does that mean? The 0 is a significant digit. I get 3 sig figs. The decimal point is kind of the start of your number line. So the decimal point actually is just saying what rule to use. That's it. Okay? If there's an explicit decimal point, the rule changes, and we now just need a significant digit to the left. I have that, which makes the 0 significant. We move to the next one down. There's that decimal point again. Is there a significant digit to the left? Yep, which means that is now significant. And now the fun question, is there a significant digit to the left of the next 0? Yes, it happens to be 0, but it's also a significant digit. How do I know it was a significant digit? Because I answered that one first. Start left to right. Okay? Which means 4 sig figs. Okay? Top one, decimal point. Do we have any zeros to worry about? No. So, just 2 sig figs. The one underneath it has a 0. Okay? There is a decimal point. If there's a decimal point, then there needs to be a significant digit to the left. There's literally nothing written there, which means it's not significant. 2 sig figs. What's to the left? Nothing. What's to the left? Just a placeholder at best. It's a non-significant digit, which then means last one. Three. Kind of get the process? I see you. Give me a sec. Okay. I do want to point out one thing, because in all of these, what I was trying to do is provide practice all the way through. You'll notice those two, it seems kind of silly, right? Why do that? Why call that out? Okay, this is getting called out for one simple reason. My pen is too nice. What number did I write? Can you help me out? What number did I write? 0.12. Some people are like, what do you mean? Look really, really carefully to the left bottom of that one. There is a decimal point. Okay? You're typically writing in pencil. How do you make a decimal point? You punch the paper. Depending on how hard you punch the paper, that lead did not transfer to the paper and you don't see it. Okay? But what if you wrote, that's an eraser. What if you wrote 0? Why would I write 12 as 0, 12? That's just enough of a pause to make you go, there's probably a decimal point, and it minimizes the mistakes. Okay? I referenced that 0 as a leading 0. You should always have your leading zeros on there to minimize that loss of a decimal point. That's why it's there. It holds no other meaning other than don't make a stupid mistake. Cool? Okay, hang on.
So, with the 120.0 and the 0.012, what's like the difference? Because they have the same zeros, but like the other one canceled out with 2 zeros. But
So those bottom two, is that what you're looking at?
the one above them, number 7.
I knew I shouldn't have erased those. So we're saying this one
Yeah.
and this one?
Mm-hmm.
Okay, say your question again? Sorry.
How does like one cancel out zeros and the other doesn't? Like
Right.
since the rule when you're saying like the 0 has to be followed by
Careful.
same, but then
With the decimal point, the 0 has to be preceded by. And this is why I don't like the word preceded, is it's too complex of a word. Okay? And for people that laugh, like, oh, that's not that complex. Preceded versus proceeded, I think mean different things. I'm even saying I think. Okay? So it's a confusing word. So really what we're saying is you need, for that 0 to be significant, we need a significant digit to the left. And I know that's not proper English there. Okay? So when I look at that lower left one that has 4 significant digits, there's my decimal point. Immediately to the left, what do I have? A significant digit. That makes the 0 significant. Okay, when I look at the last 0, what's immediately to the left?
yeah, that.
A significant digit.
But how can you do it? And it said number
It's not 0 anymore. And that becomes the challenge on this, is you start referencing it as 0. It's not 0, what is it? It's a significant digit. So change the name of it. It's not a 0 anymore because 0 has too many meanings. As soon as you've identified it as a significant digit, it's not 0, it's a significant digit. Does that help? Okay. Because then when we go over to the other side and deciding what's going on with that, Okay? There's nothing in front of it. Okay? It's not 0. It's not a significant digit. It's not a significant digit, in quotes. Right? So I've been putting X's. I don't know if you've noticed that. I put an X there because that's not a significant digit. When I look at that next 0 and I look to the left, what do I see? Not 0. I see not a significant digit, which makes that 0 also not a significant digit. Does that work? Yes?
So for number 7, when you get rid of those zeros, like our lab teacher will say, like, write in significant digits. Aren't you losing information if you don't include that?
I know what he's talking
For 7?
in general.
Like for say you get a number like that and you have to write in significant digits, if you don't include those zeros, isn't that losing
So,
information?
I don't think you're referencing significant digits. You're referencing a different topic. So if we look at that number and you get rid of those zeros, you've lost information. Okay, the information you've lost is what? So I'm not saying the number is 12. I'm saying there's only 2 significant digits. Okay? Those zeros are important. I can't get rid of them because they are placeholders. They tell me where to place the 1. The 1 needs to get placed in the hundredths place, not the tens place. Right? So I'm not getting rid of the 0. Okay? I just don't count that as a significant digit. Okay? Where I think you're referencing is not significant digits, but the step that goes beyond this. Because we can take this a little bit further and say, well, sometimes those zeros are confusing, and we can switch our format around to try and make sure the zeros are now crystal clear as to what they are. Ultimately, really, the reason zeros being confusing as significant digits or not is because people aren't using these 3 rules. Bottom line, that's the answer. Okay? If you use the rules outlined in your textbook, yes, you get... Okay? So what's being referenced is not significant digits. What's being referenced is let's convert that into a system that makes quote-unquote more sense by converting it into scientific notation. So in the conversion process of that number 7, can I delete everything? In the conversion of that number into scientific notation, my first significant digit has to go into the ones place. If it does not go into the ones place, you're placing it incorrectly as far as scientific notation goes. So my first significant digit was 1. Decimal point 2 times my power of 10. Okay, the power of 10 is telling me where to slide the decimal point. Okay, the best way to do this is see where the decimal point is. How far did I have to move it to get that 1? I just move it 2 places, so it is 10 to the second before you freak out. Is that number big or small? Okay, big, 0.012 is big, so you're going to be happy with that as a paycheck. Okay, no, so that's not a big number, that would be a small number. Okay, because it is small, what do I need to do? I put a minus there. 1.2 times 10 to the minus 2. How many sig figs in that? 2. How many sig figs did we say in the initial number? 2. It comes into the exact same system. You end up dropping the zeros that are insignificant in scientific notation. Okay? So it can kind of disambiguate? I think that's the right word. Okay? The concept of placeholders versus significant digits. Because if a 0 shows up in scientific notation, it is significant. It will always be significant. Why? Where is it? Rule 3. It will always be significant because of Rule 3. That's how it works. Okay? So that's what they're referencing when dropping those zeros.
When would it be like 1.2 to 10 plus 2? Like when would it be you use the
I'll switch that in just a second because I see another hand.
So because in our lab, she literally writes sig, fig, like question mark, where is it? So like, do how do you know the difference when she wants it as sig fig or when she wants it significant notation or whatever?
Scientific notation. If you're seeing sig fig, it has nothing to do with scientific notation, or it should not be doing to do with scientific notation. Okay, and so that could just be a confusion of the terms. Send me an email and I will talk to your instructor to make sure that that gets clarified, because scientific notation and sig figs are different concepts. Okay, so if we take a look at this number, whoop. Okay, and this is where it's going to become a bit challenging, and I have to be careful with what I write. Okay, because the question was, when does it become 10 to the positive 2? Okay, so now let's take a look at a new number, 120. I could have just deleted something else. And I want to convert it into scientific notation. What is my first significant digit? 1. Okay, followed by the 2. So 1 in the 1's place, followed by the 2. Okay, note, I'm not showing the 10. Sorry, not 10. What's the other number? 0. Why is that 0 not getting added into this? It's not significant. How do I know it's not significant? I followed rule 2. Okay? That number, according to the other sig fig rules, what other sig fig rules? Read the textbook. Or don't, because they're stupid rules. Okay? That number becomes confusing. We don't know if that 0 is significant or not. Okay, so what do? We convert it into scientific notation to try and make it more explicit. Stop using stupid rules and it doesn't become a problem. Okay? So we convert to scientific notation 1.2. I don't want that 0 anymore because it's not significant. Okay? Times 10, because I had to shift the decimal point. Okay? Now becomes the question, and this is why I had to kind of back things out a little bit. How far did I move the decimal? Where is the decimal point implied? Okay? I don't know. Is that number 120 or 1,200 or 1,200,000? It's 120, right? Does anybody want to challenge it? They're like, no, that's 1,200. Okay? So there's an implied decimal point in how we've written that. Okay? And that's where things become nasty. The decimal point is really easy to lose. So be explicit with it and it's okay. In this case, I haven't specified that decimal point. Okay? It's implied. It's not necessarily always with the 0. What number is this? 1,220? No, it's 122. Where's the decimal point? It's after the 2. Okay? Your decimal point is implied to be at the end of your chain of numbers. Okay? And it's either explicitly stated because it's in the middle or it's at the end. Okay? So in this case, there's my implied decimal point. How far did I move it to get to the number 1.2? I moved it 2 places. So again, it is a 2. 1.2 times 10 to the second. Is 120 a big number or a small number? Okay, big-ish, and we'll address that ish here in just a second. Because it is big-ish, that is a positive. Do I need to write a positive? No, you don't really have to. It doesn't hurt to do it, and I don't think anybody's going to take off points if you do write it. Okay, so that's why it becomes positive too. Okay, big and small. Okay, so back to that concept of big and small. Big and small is all relative to 1. That's it. If it's smaller than 1, negative. If it's bigger than 1, 120 is bigger than 1, make it positive. Okay? That's what the minus and the plus are really referencing. Okay? Kind of makes sense? We cover all those nasty bases? And it sounds like there might be some confusion with scientific notation and sig figs that I need to clarify. Okay, with your instructors. Okay? Because it can never be easy. How many quarters are there? Not even sure. See, this is where it becomes fun. Okay? This is literally just how many objects are there, and you're like, I can't count that high. We can understand numbers bigger than 10. There's less than 10. 1, 2, 3, 4, 5, 6, 7. Yeah? That help? So we write that at 7 quarters. Yeah? How many significant digits? 1. Okay, if you're saying 1, then you're saying that this could possibly be 7.1. Two significant digits. So it's not 7, it's 7.0. So you're saying 7.01 is a possibility. Try me. Someone want to go for 3? Okay. There are some numbers that have infinite sig figs. When we count objects, those tend to be infinite sig figs. Okay, within a certain realm. That realm can be very, very ambiguous and vague, so we tend to not address it too much. Okay, it was 7. We kind of figured that we could deal with that because it was less than 10. If it became 20, we now increase the odds of someone screwing up that calculation, and so the significant digits could potentially fluctuate. But in general, in the counting process, we're usually half decent up to 100, and then after that, we start to incorporate error. Okay? Where this becomes more relevant is not so much in the counting process, but in conversions. 1 foot equals 12 inches. Okay? You can take your pick. Which side do you want to look at? Left or right? Left. Okay. How many sig figs in 1 foot? Because if you're going to say 1, then 1.1 is an acceptable answer for this conversion. Okay? It's infinite. That is a definition. That means that those numbers, when placed next to those units in this expression, have an infinite amount of sig figs. They aren't a measurement, they're exact. Okay? There are certain definitions that encounter exact things. 1 foot is 12 inches. There are 4 cups in 1 quart. Was that a question or an answer? Because I didn't know. Right? Those are defined, which means they have infinite sig figs. Okay? Is that going to become important? Yeah, particularly when we move to English versus metric conversions, because those aren't necessarily defined anymore. And those become accepted conversions. Depending on what we're trying to do, we may need more sig figs than in other cases. Okay? So, why do we care? Okay, ultimately, the issue with sig figs is what we do with subsequent calculations of those measurements. Okay? Which means mathematical operations, addition and subtraction. The result is only as precise as the least precise measurement. So when we add those two things up, what do we end up getting?
1, 1, 5, 6, 3, 3, 6, 2.
Someone was really good at the math. Nailed that down. Okay? How many sig figs in that answer? Okay, and I'm not saying how many is correct. How many are significant digits are in that answer? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 significant digits. How many significant digits in this top one? 4. And the next one? And the next one? 5, and the last one was 8. The number of significant digits has changed through our calculation. Okay, that becomes a bit odd. Something weird is going on here. We have to have an explanation for it. Okay? Add to this, we've made some massive assumptions in this answer. What did we assume when we came to this answer?
All these things can be added together, whatever these values are.
They're all grams, so yes, they can all be added to each other.
That, like, for the 1, 4, 2, and 3, that the remaining placeholders were all zeros.
That all of those values were zeros. But remember, how do we take measurements? We report all of our absolutes, and then we get one guess. you have now just said that all of those zeros, okay, or at very least these first three, are absolute truths. Is that true? No, because if it was true, I would have written them. Okay? The 3 was a guess. You're now putting information into your equation that you don't know. Those could be zeros. That is true. They could also have been we could argue anything. What if they were 9s? How does that change your calculation?
Changes the last 5 digits.
Really good at addition. And we end up with that number. What did we have before?
6362.
What did you say it was? 1.156.
1156362.
Are those two calculations different? Okay. For those people still wondering, that's okay, because a couple other people have shouted it out. Let's go through and look. I have a 1 in the hundreds place. I have a 1 in the hundreds place. Are those the same? Yes. 1 in the tens, 5 in the ones. Where did they differ? In the tenths place. Go back up to the data that we started with. That first number reports out to where? The tenths. The next one, I don't know where that place is, but it's further out there. The next one, further out there. When we do addition subtraction, guess what? You have to round your answer or truncate your number up to your first guess. Okay, your first guess place. Read the box. The result is only precise as the least precise measurement. That measurement's the least precise because it gives me the least number of decimal values. Okay? Why do I need to report to that place? Because that's where it differed when I did the addition. Okay? The rule has a meaning behind it. That's where that place is coming into play. Okay? So cool, now I've got those sig fig rules, and now I just have one more rule to worry about, right? I just have to make sure that when I do my calculations, I report to the least precise measurement.
When you do that, do you round?
Okay? When we do that, do we round? Yes. Okay? We don't want to delete all of these, sorry, let me get the place right. We do have information about those places. So when we do the addition, we have to keep those in the calculation. Okay? And if that next number was close enough to the next value up, we could round up. Is that first insignificant digit close to making that an 8? No. So what do? I round down and keep it at 7. Okay? So we are rounding in this case. This particular example did not require a sequence of rounding because the number just comes out as it is. Kind of, sort of? Okay, so you have to know these rules when you manipulate your sig figs.
So what was the purpose of showing us the calculations of all the 9s?
To show that you see a difference in the numbers. And where did that difference appear? What's our rule? Least precise place. Okay?
So is the goal to just be absolutely precise with every calculation?
So what really comes out of this is that when we go through to do this, do we have to worry about this in the lab? Okay? Would you take the mass of an object on one balance and then take a mass on a different balance and the mass on another balance that all had different precisions and then try and add them all up? No. Okay? For a couple reasons. One, why would you have that many different precision balances? That just seems a bit silly to have in the lab. Right? So we don't do those kinds of things, and we don't experience this often. Okay? But we do experience it in other types of calculations. The calculation we'll see on the next one. Okay? And we'll address that here in a second. Where this becomes more important is when we do subtractions to get volume changes. Okay, we want to make sure that volume change is as large as humanly possible. Because if it's not as large as humanly possible, the answer I get from that volume change is a guess. Okay? I actually don't know anything about it. Okay? You might wonder where that would appear. You already know where it should appear. You all took that lab, right, where you did the density of a metal object? How close were you? You were off by 3 grades? Is that what you said?
I got an F for that assignment, but no, like, I think the lowest should be the 1.7. I think I'm like 0.8 grams somehow.
Okay. So you were way off. Anybody else? Yeah, way off. Why were you way off? The volume that you got was a very small volume, which meant the error in that measurement was astronomical. Which then means when you move on to the next calculation, what happens? Your next calculation's error is that much larger. Okay? So that's why you need to be careful when dealing with calculations in lab. Sometimes we'll blend different calculations, typically not through addition and subtraction. And it can result in massive amounts of error. Okay? So what happens when we move to, multiplication and division? What is the area of that square? How would I calculate it? Length times width, 7.28 times 4.6. Okay? And we get 33.488. Okay, unit squared. Don't worry about the units right now. Right? Okay? If you tell me that that's your correct answer, you're wrong. What did you not take into consideration? Significant digits. Okay? If we go back and look at our significant digits, we've got one number going to the tenths place, which is admittedly misleading. I apologize for that. Another number going to the hundredths place. If we look at the answer, we're reporting out to the thousandths place. Right? We can't do that. It's only precise as the least precise place. Shouldn't it be, 33.5 because the 8 was larger and add 1, right? Okay. That would work great if this was addition-subtraction. Addition-subtraction is a different system than multiplication-division. So we can run the exact same thing we did with the addition-subtraction now with multiplication and division. Okay. When we ran our calculation, we were assuming that that was 460. It could have been 469. If it was 469, what number do I get? Okay, 34 versus 33.488. Where did those numbers differ? In the ones place. Well, none of the numbers given here were precise to the ones place. Why am I differing at the ones place? New rule for how error propagates through multiplication and division. The new rule is that your error is going to be based off of the fewest significant digits. So go back and look at your calculations. 7.28 had how many sig figs? 4.6 had how many sig figs? 2, which means your answer needs to be reported to 2 sig figs. So we go back, whoops, waste way too much. Starting with the 3, what's the next significant digit? 3. Is that larger than 5? No. So what happens? Our answer becomes 33 units squared. And before we start going, but you're losing all of that information. No, we're not losing any of that information. All of that was random guessing. Okay? I can't keep that because it's guessing. This number is actually a more accurate representation of what I've got measured. Okay? So the rule changes when it comes to multiplication division. Are there other mathematical operators? Yes. What happens if you do a different mathematical operator? You get a new rule for how sig figs propagate through it. Yay! You know what's awesome about these mathematical operators? You only have to worry about these 4, which means only 2 rules. Okay? Okay. The rounding option, been told that I'm actually not as precise as I could be on this, but this is close enough. Okay? Look at that first non-significant digit. If it is less than 5, then just report as normal. If it's greater than 5, then add 1. So let's take a look at the addition-subtraction example. Okay? Because it is addition-subtraction, I can only report to the least precise place. Which of those numbers is the least precise? In the red box. Top or bottom? Top. Where is it precise to? Okay, that tens place for that 5, which means my answer needs to be reported to. That's not tenths for the record. That's hundredths. That's why I underlined it and said 5. I promise. So 1, 3, 3, right? First insignificant digit is 5, so what do I need to do? Add 1, my answer becomes 1.34. Okay, multiplication division. My answer is only precise as the fewest number of sig figs. 7.8 has 2. 4.68 has 3. How many should show up in my answer? 2. So 3, 6. 5 is the first insignificant, so add 1 and my answer becomes 37 units squared, yeah? Cool? Okay, we're just going to throw this out here. Is this like coming out of left field and that's why it's silence? Or is this silence because you're like, this is dumb, I already know it? Or is it coming way out of left field, like, what the hell, where did all this come from? Yeah? Okay. It should be review, it may not be review. This is why the lectures are recorded. Go back and rewatch. Okay, and work through those examples. Get that practice. In fact, here in a second, I think we've got some practice. Yes?
What's the difference between the least precise and the fewest significant digits?
Fewest significant digits is just how many numbers there are. Least precise is where do you stop writing numbers.
Okay.
So it's counting versus last place, which is, I wish I had a better way. Okay? Okay. One of the reasons why this can be frustrating for students, okay, is that the textbook is inconsistent, online homeworks are inconsistent, and instructors are inconsistent in following sig figs and rounding rules. Okay? So it can be exceptionally frustrating. It is something that whenever I work an example, I try my best, both in examples and in exam questions, to ensure that if you are using the numbers that I have given you, that you will get to the same place that I end up at. Okay? What do I mean by the numbers that I've given you? Okay, we've done a whole lot of number stuff here, right? Where are there numbers that you might be given? So we can list questions out off the slide. Okay, and to that end, where are there numbers? Before you start doing that. Where are there numbers that I have given you? The periodic table has a crap ton of numbers on it. You will be expected to use those numbers in calculations. Okay? Garza. What is the mass for tungsten? That would be the symbol W. Okay, for the record, I'm asking somebody in this near corner. Okay, other people on the far side are also now squinting. What becomes the problem with looking at this periodic table? It's really hard to see, which means, yes, you can pull numbers from it, but there's a more likely place that I would expect you to be looking for numbers when it comes to an exam. The periodic table on the exam. Use that. Use the numbers reported from that. This is why it's so valuable to have that printed with you when you come to class, to use that to run your calculations. Okay? Because that's the numbers that are going to show up in your calculations. That's the numbers I use to solve questions on the exam. It's the one place that I can guarantee you have access. Okay? Are all those numbers 100% true? Nope. Hydrogen at 1.01, if you go to the tutoring center, I think there's one periodic table in there that says it's actually 1.008. Which one's more correct? We're like, I don't know. 1.008 is more, is more correct because it's more precise. Why did we need more precision? Because the calculation that was being run at that time needed it. Do you need it? I don't know. Look at the problem. Okay? That's where things can slide, particularly on online homeworks in future chemistry classes. Okay? So to that end, would you guys like some practice? Yeah? There you go. Bunch of practice. If you've got questions, raise. So the top two for sig figs, we've got the work shown, though I don't think I actually specified the number. For that first one, we have 3 sig figs. For the second one, all of them count as sig figs, which if I counted right, came out to 6. Okay? For question 3, there's a bunch of stuff stacked on there. So let's go through that. When we go through and just enter it into the calculator, we get that purple number, 129.041. Okay? The calculator spits that out. How much of that are you allowed to keep? Because it is addition, we are only allowed to keep up to our least precise place. Okay? So we would have to go back and look at the numbers that we were given and decide their least precise place. So in the first one, it went to the thousandths place, then it went to the hundredths, and then thousandths. Okay? Hundredths was the least precise place. Okay? Which means my answer can only be reported to the hundredths place. So my number becomes 129.04. Okay? A question was brought up where they're like, oh, that number has 3 sig figs, and that's what dictated it. That had nothing to do with it. Okay? If I changed this number in between there to be 0.0, I think we can pull this off, actually. What was the number? I already forgot. 3.09. When I enter that into the calculator, am I going to get the same number? Yes, right? Those zeros aren't changing anything. Does that change the answer I report?
Yes.
Yes. Okay, and actually there's 1, 2, 3, 4, 1, 2, 3. Sorry, I just realized another pattern. I'm trying to break a question before it happens. That'll work. Okay. What does my answer become?
041.
Now it goes out to 041. Why am I allowed to report that extra decimal? The least precise place is now the thousandths place. This one went tenths, hundredths, thousandths, ten thousandths, right? Okay. So now I can report out to the thousandths place. That had 4 sig figs. This had 5, that had 6. But I'm still using the 5 sig fig one. Does that make sense? So you're looking at different pieces of information. Addition, subtraction is the place. Okay, and that's why we call it the least precise place. When we move to multiplication, division, the next one down, you'll notice I'm saying another thing that means small, right? Least means small. But except instead of saying least, I say fewest sig figs. Why am I changing the language? I'm trying to separate those definitions as much as humanly possible so you don't confuse them. Okay? So in multiplication division, it's now the fewest sig figs. So when we go through and look at those exact same numbers, the one that's going to drive that is this middle one with 3 sig figs, which means my answer can only be reported to 3 sig figs. When I multiply it out, I get the number in blue. 4,538.47701. Okay? There are two common answers that come out of that, 4540 decimal point and 454. They're like 3 sig figs, 454. I don't want to put a 0 because I don't want it to be significant. Okay? You're right, you don't want it to be significant. If you understood that you were going to get paid $4,500 and they came in with a check for $450, are you going to accept that? No, they're going to be like, oh, it's significant digits. No. Go back to chemistry class, you don't understand significant digits. Okay? That 4 needs to show up in the thousands place. The way to get it into the thousands place means I need a placeholder 0. So I have to have that 0. But if I add a decimal point, now what becomes the problem? Now I made the 0 significant. So that is also not allowed. So that 0 straddles that weird gray area. This is why, if you don't follow the rules as clearly as outlined, you might shift to scientific notation and say it's 4.54 times 10 to the positive 3 so that you get the 4 placed correctly. Kind of, sort of? Okay. It takes a little bit of manipulation to get used to. When it comes to significant digits, how important is it? Well, if you plan on being a scientist or an engineer, it's really, really, really important. Okay. If you don't need to be a scientist or an engineer, but you need 151 and 152, it's really, really important. Okay? And depending on who your instructor is, sometimes you get varying kind of responses to significant digits. Okay? But again, my issue with significant digits is that we inconsistently apply the rules based off of sourcing our data, which means rounding things changes, and we get all sorts of weird gray areas that causes all sorts of problems. Okay, so I just want you to be aware of that when manipulating your numbers when it comes to significant digits. Okay? I would recommend putting it all on one slide, so much so I did. Okay? So you could download the slideshow, print out that one slide, and now whenever you do your calculations, you're there. Okay? And you've got all those rules established and you're ready to run with them. Make sense? I still got 3 minutes. If you want to leave, that's fine, but I'm going to keep talking. Some simplifications. If we tried to write that calculation out, you would probably get irritated by the amount of calculations that you were doing. You might also get irritated entering it into your calculator. So what might you do?
4 to 6.
You can use powers to deal with that. So 4 to the 6. Okay? That can shorthand your calculations significantly, which is really nice, which is why we can take advantage of it. Okay? There are common ones that show up. You'll get squareds and cubes. Squared because why is that squared? Everybody's like, it's 2. Because 2 is a square? Why is it a square?
2-dimensional.
Length times width. Okay? Length times width. You're squaring them because you're taking the area of a square. Cubed. Length times width times height. There's 3 different things. That's why it's cubed. Okay? That's where those things are coming from. Powers of 10. This is ultimately our scientific notation. Dealing with what those powers of 10 mean will become much more important when we deal with conversions in metric, within metric, or even metric to other systems. Okay, so you need to be familiar with your powers of 10 and what it means shifting around. Within our scientific notation, did I actually fix this stupid slide? Yeah, I did. Awesome. Officially, first significant digit in your ones place, then list the rest of the significant digits, then power of 10, number of times you moved the decimal, and then positive or negative, depending on if it's big or if it's small. Okay, that big and small was all relative to 1. Okay? How many significant digits in that first measurement? 1, 2, 3, 4, yeah? What if I said when I measured that with a 1-foot stick? How many significant digits was it? Okay, we got a suggestion for 9. 1, 2, 3, 4, 5, 6, 7, 9. Why did it all of a sudden change? the exact same number.
It's how you measured it.
It's how I measured it. How I reported it hid how I measured it. Okay? If I want to report it out where I want that ones place to be at 0 for a foot, that makes, I have to put in a decimal point. What if I measured it with a 10-foot stick?
You mean meter?
No, a 10-foot stick. A meter is 3 things. I see what you're saying. Shh. A 10-meter stick. I would now need to report to that. How do I place a decimal point where that last 0 becomes a placeholder? Think about that one. See what you come up with. We'll start there Tuesday.